For centuries, we've looked at the stars, searching for meaning, mapping constellations, and constructing theories to explain our place in the universe. But something has changed. The James Webb Space Telescope, humanity's most advanced eye on the cosmos, has begun to return data that doesn't just challenge our understanding of physics and cosmology, it annihilates it. Galaxies too massive, too early. Planets that defy the laws of formation, structures too symmetrical for randomness, and a repeating signal, faint yet flawless, that no known star or mechanism could explain. It's not just a discovery. It's a collision between what we thought the universe was and what it might truly be. And if what we're seeing is real, then the universe is not a place of chaos. It's a system, a message, a memory. And James Webb may have just read the first sentence. One of Webb's first deep field surveys turned its attention to the cluster AEL 2744, a chaotic ballet of galaxies distorted by gravitational lensing. But embedded within that chaos were points of light arranged with an unsettling precision. Symmetrical patterns emerged, alignments that appeared mathematically deliberate. At first, they were dismissed as artifacts, coincidences in a sea of randomness, until they showed up again. In NGC 1365, a spiral galaxy, Webb recorded motion that contradicted gravitational expectations, rotations that seemed choreographed rather than governed by mass. Across other fields, the telescope continued to find these patterns: perfect rings, mirrored formations, evenly spaced clusters distributed across billions of light years. Over time, the number of these symmetries grew too large to ignore. Were we looking at galactic coincidence or evidence of a geometry we've never recognized? As the data mounted, one thing became clear. The deeper Webb looked, the less chaotic the cosmos appeared. The universe wasn't random. It was behaving as if it remembered something. While the deep field revelations unsettled theorists, another discovery sent planet formation models into complete disarray. Webb turned its infrared gaze toward HIP 65426b, a gas giant more massive than Jupiter, orbiting a young star hundreds of light-years away. But this planet defied every known rule. It was 7 times the size of Jupiter. It orbited at a distance 3 times farther than Neptune, and it existed around a star only 15 million years old, far too young to have allowed the planet to form through traditional accretion. Worse still, there was no visible protoplanetary disk, no dust, no debris, just a massive glowing world suspended in space where theory says it should not be. Some have speculated it might be a remnant of a previous system, somehow displaced and captured. Others whisper of more radical ideas, a rogue body engineered, positioned, or preserved. For now, the planet hangs there, hot, massive, and inexplicable. A riddle the size of a world. In one of Webb's most startling images, a gravitational lens formed by galaxy J418 revealed something so rare that even seasoned astrophysicists were stunned: a near-perfect Einstein ring. A flawless circle of light, unbroken, undistorted, as if sketched with compass and ink. Gravitational lensing is a known effect when a massive object bends the light of another behind it. But for a ring to be this perfect, the alignment must be unimaginably precise. The margin for error is infinite decimal fractions of a degree across billions of light-years. It should be nearly impossible. And yet, there it was. This wasn't just a case of gravitational physics. It was geometry manifesting with intention. Some scientists now wonder if this could point to a deeper symmetry within spacetime itself, perhaps not randomness at all, but a cosmic grid we are only beginning to detect, a hidden structure underneath everything. And Webb just glimpsed it. Then came the blow that broke the foundation. In a region of space thought to be young and chaotic, Webb found galaxies that should not exist, fully formed, spiral-armed, and massive. Their light indicated that they had formed just 180 million years after the supposed Big Bang. But galaxies, according to every standard model, take billions of years to evolve into that kind of structure. And yet here they were, massive as the Milky Way, glowing with stars, ordered and stable. Their very existence violates the timeline of the universe. If they are real, then either the universe is far older than we believe, or our understanding of how structure emerges from the void is fundamentally wrong. The data cannot be ignored. The models can't contain them. And some scientists now wonder, did the universe truly begin in a single explosive moment? Or did it inherit its structure from something older, something passed down, preserved, or recycled across cosmic cycles? In one of Webb's most perplexing findings, It detected a gravitational lens effect, light from distant galaxies bending sharply, yet no massive object was visible in the foreground. No star, no galaxy, no black hole, just empty space. But the lensing was real. Light curved precisely as if there were a massive presence anchoring space itself. For decades, dark matter has been the go-to explanation, a mysterious invisible substance that exerts gravitational force without emitting light. But this distortion wasn't diffuse. It was sharp, localized, with borders. It behaved less like a halo of unseen matter and more like an object, a structure. Some theorists proposed that this might be an ultra-condensed dark matter filament. But others offered something more radical. What if it's not dark matter at all, but a gravitational echo, a remnant, the imprint of something ancient, no longer there, but still warping space as if it never left? A ghost in the fabric of the cosmos. And if true, it means space might carry memory, geometry forged by forces we've yet to detect, or civilizations we've never imagined. As Webb continued mapping intergalactic regions, it stumbled upon a cosmic filament unlike any ever recorded. This was not the kind of vague web-like structure we've seen in simulations. This was precise, a billion-light-year strand of galaxies and dark matter aligned in a way that resembled scaffolding, parallel lines, equidistant nodes, rhythmic voids. It didn't resemble the chaotic diffusion expected from gravitational collapse over eons. It resembled a blueprint. The cosmic web has long been seen as the natural consequence of matter clustering under gravity, forming filaments, walls, and voids. But this filament defied that assumption. The regularity of its structure, the harmony of its mass distribution, even the redshift gradients hinted at deliberate construction, or at the very least, preserved information. It was less a web and more a framework. As if the early universe crystallized around a pattern, one embedded before time could smear it away. And the more data Webb fed into the models, the more this filament began to look like something terrifyingly precise, like the skeleton of something larger hidden beneath the flesh of galaxies. As scientists struggled to explain the repeating patterns, perfectly shaped lenses, and impossible galaxies, a controversial hypothesis began to resurface, one that treats dark matter not as inert substance, but as memory. What if the vast invisible sea of dark matter that makes up most of the universe isn't passive at all? What if it records, stores, transfers structure across eons? Webb's observations of galaxy clusters showed mirrored formations separated by billions of light-years, arrangements too similar to be random. Some began calling them echo galaxies, clusters that reflected one another in structure, star distribution, and chemical makeup. But how? The only common factor between them was the invisible scaffolding of dark matter. If dark matter retains impressions from previous cycles, then what we see in our universe might not be purely new, but repeated, modeled, inherited, like ripples echoing through a pond long after the stone has vanished. And if that's the case, then every star, every void, every spiral arm might be a whisper from a cosmos that came before this one. And then came the most haunting discovery of all. During a deep scan of a seemingly empty region, the James Webb Space Telescope recorded a faint pulse, light fluctuations so precise they bordered on mechanical. It wasn't a pulsar. It wasn't a quasar. It wasn't a data artifact. It was too weak to be natural noise, too clean to be stellar chaos, a single point of origin. No visible source, no measurable mass, just a rhythmic flash repeating every few milliseconds, timed to a level of accuracy no known astrophysical object could maintain. Analysts ran simulations. Engineers tested for glitches. The signal remained. One scientist anonymously described it not as a message, but as a marker, not meant to be decoded, just noticed. Like a lighthouse on a forgotten shore, a warning, a test, a memory left behind for whoever would someday look deep enough. Whatever it is, it's still there, silent, repeating, as if the universe itself placed a breadcrumb in the dark, waiting for someone someday to understand what it means. We built the James Webb Space Telescope to look back in time, to uncover the silent echoes of our origins, to make sense of the chaos we thought ruled the early cosmos. But instead, we found order. We found symmetry. We found memory. Galaxies that shouldn't exist. Planets that defy logic. Rings too perfect for chance. Pulses without a source. And beneath it all, patterns, not just in space, but in time. In the way structures repeat. In how darkness holds form. in the possibility that the universe doesn't just exist, it remembers. And that memory may not be random. It may be deliberate. What if what we see as the cosmos isn't the full picture, but only a surface, like the skin of something vastly more intelligent, something that builds, reuses, observes? Maybe the universe isn't a place we live in. Maybe it's a language. And every anomaly, every gravitational echo, every impossible filament Webb uncovers is a syllable in a sentence we were never meant to read this soon. But now we have, and something deep in the cosmic silence has shifted. So what do you believe? Is the universe older, smarter, stranger than we ever imagined? Are we seeing the fingerprints of something far beyond nature? Leave your thoughts in the comments. Like this video if it made you question the stars. Subscribe and turn on the bell because the next image from James Webb could change everything.